So, in the previous section, I possibly had more answers than the questions. So this time I have more questions than answers. This is a set of problems which I don't have an answer. And like I don't have any results from our own research also in this. So it's very, very different flavor. So the objective is to tell you that, look, when we practice AI today, we are seeing the success stories, like the hype that people we read everywhere. There are a number of other dimensions which we need to be aware of. As practitioners, as researchers, as students, we need to be aware of a lot of things. Now, how this, what you are aware of it, is getting reflected in your own action may be difficult to summarize in one sentence and one step. So you have to be careful from both sides. Okay, I want to say, so sometimes when I show this nice lip sync videos for creating educational content in Telugu, people blame me and saying that, okay, this is deep fake. So I asked the question of, when I am starving for food, you are teaching me the nutrition value of the food. It is important to realize both sides. What the world is looking for, when the country is short of doctors, when the medical screening at the rural areas are difficult and impossible today, and technology can make inroads at that level, you talk about the FDA regulations, or you are talking about the governmental regulations, you are talking about the testing, the correctness of the systems and accuracy of the performance. It's a complicated space for anybody to take a stand. Okay, so I wanted to start with this controversially saying that, look, it is not like one-sided argument that AI has to be trustworthy. AI has a problem solver, AI has a trustworthy. Both these arguments will have to coexist. If you take only one side of argument, you may be handcuffed very soon and you may not be able to make any move. So this old story about there is somebody who studied the anatomy of the cow was given finally a stick to beat the cow. This guy is not able to. If I beat here, this will happen to this cow. If I beat here, this will happen. So I am unable to do anything. When the cow is or something is attacking you, you are worried about all these issues. So the question is about you need to understand when you need to solve the problem of sending this cow away or this animal away. At the same time, you also need to know where all you can hit mildly or forcefully on this animal without doing any life damage or anything in the futuristic damage on this animal. So you see both type of things. When people argue, when you practice, people ask you this question where did you do this? Is it ethical, unethical? This, or hundreds of questions that can come when you walk. But so you have to understand this both sides. So it is important for you to be aware. You cannot be blind on this. So you have to, the coexistence of both parties is very important for the natural growth of the community. Only the lawmakers and police cannot help in the natural evolution of a society. The laws will have to be updated according to the social needs. So this is a very important aspect to realize. So because I make this a counter statement before I get into the pro statements is because it is important for us to realize both sides. So just keep that in mind. So let us understand what happened. So this segment of the lecture is mostly Just to tell you, the too many dimensions exist today which we possibly never thought and never realized what is going to happen when we were jumping deep into this AI wagon maybe 10 years back. And now people are talking about it, and the beauty is this entire space has now taken a shape in the sense of what all keywords and how they are connected and what are they dependent, etc. And there is no way I can do justice to how the depth of all these aspects, as well as what solution that you can keep in mind to minimize these sort of issues and how to avoid, etc. in your solutions or in your research and your work or project or whatever you do. But I'll try to give you a glimpse of this. So this entire journey of AI, if you look at many years of GI, so people talk about winter and summer. So this has a very, very long history when people started to talk about perceptron. When perceptron started to work, people thought that we have solved the human brain problem. Electronic brain can be built with perceptrons. Then MLPs came and the MLP was shown that XOR cannot be solved, and that was the end of things. So there was always ups and downs of this. When we were able to solve a class of problems, the world will think that everything can be solved, and the journalists will write in such a way that everything in the world is solved. And we all believe that. And as a result, a lot of people will get panic, and a lot of people who have money will invest in startups and invest in things, and then a lot more other interesting things will happen. And all of them are continuous stories, so even now you to see today. So that money that is flowing into the AI has also attracted a lot of people into the room. Many of you are here thinking that you will get an AI job. Isn't it? So all these issues also happen. So these ups and downs come, and then sometimes algorithmic, we will see that algorithmically you cannot solve an XOR problem style of very tough, hard realities come, and then back propagation algorithm will come back and rescue it, and then the MLP will rule the world for a while. So when we were all students, MLP was the end of everything. You can always write a paper. Anything that was done with some other technique, you say you are using MLP, you will get a paper. That's how we all got PhDs. then what happens? Then that was not enough. When we move forward, and then we realize now MLP is not solved. Oh, MLP, this is a complete nonsense. You cannot solve this problem. You need to have proper convex optimization. The era was of convex optimizations. Beautiful principle mathematics. Boyle taught us a lot about what happened in that space. And support vector machines, kernel methods, they ruled the world for a long time. Then people came back and told Alex networks. We never built it. Okay, AlexNet also we never built. Many people were not believing that in 2012 when this paper got published, this is reproducible. In 2015 also when Cafe, the first possibly open source library came, so look, history is not that old. All you are seeing today, first open source library possibly came in 2015. And that is where I think when we did the Indian Summer School 2016, that is where we started our summer school series, and we wanted to teach the Indian students programming in this space and enable them. We were debating a lot what programming language we should use. There are many options, Cafe, Piano, I don't know with all these names you are aware of it today, etc. And so only the multirationals survived TensorFlow, and PyTorch left in the game now. So there's a monopoly evolving. Notice, it's all open source. Doesn't mean there is nothing wrong. Open source is not the end of the world. Free and open source people believe that is the end of the democracy. It is not really. So that era happened, and then systematically you see people I said 2015 is not long back. 2016 we started summer school series, and then 2 year, 3 year down, we were clear what type of programming language and frameworks are surviving, and all the laboratories and exercises. So they use proprietary clients, YouTube or Zoom or something. So you don't receive a Zoom call on your Teams client. Or but at the same time you can make a phone call. You can make a phone call from my Airtel to your Ncell. My carrier provider need not be the same. I can make a phone call to you your numbers from my phone, my Geo or Airtel to your own, your favorite Edsel, I can get it. But it doesn't work for Zoom. It doesn't work for many of such streaming devices. So what happens is standard versus proprietary game. And what is proprietary trick? Proprietary is the client. And what is this proprietary client is doing? It uses a deep learning model. Now I can publish the deep learning architecture that I do of no use, because at the end of the day, what data that I trained really matters. And that is not public. So what does it mean by open source today when your deep learning model is public? I cannot really train all the data on that, or I cannot provide. So there are very, very different levels of question that you can ask. So AI is everywhere. This is healthcare, robotics, that's another area. We talked about multimodality in the morning. The next thing that we missed is possibly the movements of the humans. You can interact with the world. The robotics, I think a lot of things happened, though the progress in this space has been far slower than what the world was looking for, and the robotics and the associated manipulation of objects, particularly maybe because of the challenges in the mechanical areas, or the research was possibly slow. A lot of things that possibly did not happen at the pace that the world is looking for, but still the algorithmic the changes there has helped us to solve interesting problems. Education, we talked about a lot in the education space that we all got used to now, today, quite natural. But still, we discussed that, okay, we still don't do enough in terms of personalization of education, making impact. A lot of things happened and a lot of things still unsolved. Many working solutions. Face-based screen locking, like a class of phones possibly may use that. Or chatbots, I think Alexa or whatever it is, etc. So these sort of things have become so, even this sort of pieces, like I don't know why it has penetrated so deep into the society today. Like I could have thought this is like a fancy piece. And I got something like this, like a small piece, a gift from somebody, and I thought it is of no use to me. And somehow I connected at home, and one day I started to see that my son is enjoying, like he's a close friend, when he's alone, he'll ask, look, tell me a story, he tells a story. I never thought it can do such things. And he keeps on asking, what's the capital of this country, what is the capital of this country, he keeps on asking all general knowledge questions, and this answers, and so these sort of things become the next generation, the society. I think people at maybe our age possibly never use that enough, and we still use even internet for most of us. When we started to use it, was an information source. It was not like we were living with it. So some of these technologies have gone so deep into our life. I still don't know how to use CD or something on my phone and use it. I still don't speak to it. I still want to with a lot of difficulty sometimes. So maybe the new generation becomes all very natural today. Many working solutions. Self-driving cars during pandemic, medical diagnostics at like not just this, COVID possibly, because COVID there are like a lot of interesting things. Everybody wrote a paper on X-ray how to screen with for COVID. So a lot of things happened. Medical, like all the screening, people say yes, there's a nice interest I don't have that picture here now, what type of algorithms reach what level of acceptability, what level of legal regulation, distribution, how to do it, etc. Critical systems. So what happened is when this got into the use, so we started to enjoy. I think the citizens, like everybody who use this is enjoying, they find the benefit out of it. But there is a worry about what is it's going to be the impact. Say for example, think of military. What is the impact on it in military if it makes 2% error? The 2% error, like a 2% or 98% your paper will get accepted, isn't it? But 2% error on a military task, I don't know, or a like a medicine task or I don't know, or finance. It's dangerous. So in many areas, the concern has been on what is the this sort of errors can result. So that's where people started to worry first. But it is not just the accuracy alone. This sort of news game, I have no idea what goes on there. Robots started to talk to them in each other in a new language. So think of the journalist, like look at this, some encoded bit stream moving from one neural network to another neural network is what this guy is talking about. So you might have heard this news, isn't it? 2017, many of you may be old enough to read newspaper by then. Facebook robots communicate in a new language. As if the world will be conquered by them in next 2 years. The movies tell you this sort of things are going to happen and you're all getting ready for that. Self-driving car going to hit somewhere and then some accident happens. When self-driving car kills a person, you're worried about it. You make all the noise, all the media is behind. When a road accident happens on Kathmandu Road and 10 people get killed, nobody keeps silent talk about that. Why? Why? Pardon? A is glamorous. So it is the glamorous people use you, you will get more money. If the celebrities use you, you will get money. That is how you make money. Lawyers make money. You sue celebrities, they have money, you will get, they will settle the account fast. While you sue a common man, there is no money available, you will not get money, isn't it? No? So why we are not talking about the accidents that happen when the human driver acts, when human driver kills people, while like a self-driving car kills, you speak a lot, isn't it? Why?
People are fearful of unknown things.
People are?
Fearful of unknown things.
Fearful
That
of
can
unknown.
more appropriately understand.
No, but see, you look at, I just want to give you statistics. You never looked at statistics.
Yeah.
So what is a percentage accident that happened per kilometer or per whatever mile or whatever you take for the self-driving car versus per kilometer accident for the type of car that we all drive here? Do you think which will be higher? Humans will be far higher. No, but why are you speaking? I'll talk about people who build later. My question is about why you as a common man, why you as a journalist, why you as a layman speaking a lot about this when and you keep mum about when people die, tons of people die on the roadside in front of our eyes. We have high expectation on AI. Pardon? Pardon? I'm not talking about that. I'll come to some of these issues. But my question is about why are you speaking a lot about only one type of issue? Why are you keeping silent on the most important thing that is happening in front of you? Pardon? There's a physical entity to blame when there's a driver here. And the physical entity you don't want to blame. The car, the road transport, the minister, the many things we can blame when the accident happens here, isn't it? You have trust or you don't have trust? You don't have trust. While human driver, you have all the trust. And then it makes an accident, and you have a trusted person making an accident, you keep silent and salute him. So it's important. So I just want to provoke it by saying that look, you cannot take this one-sided view of in all geographies most particularly. You see this sort of nice interesting stuff happening everywhere. Increasing worries. But everywhere. You don't know what is going on. So you have, I don't know what's the problem. We are worried about something. Maybe we are losing control over AI. Is that the worry? Human driver, you anyway have no control over that person. You can control only while giving a driver license. That's the best you can ever do. After that, you have never control. But software, you think you have control at any point. So this entire story has many dimensions. So this is the background. So we are seeing this issue of AI today with a lot of concerns, and everybody is complaining about it. And complaints, while complaints are true, I also want you to understand the complaints and reality in a more holistic manner rather than a biased manner. You want to understand why this happens. You want to understand without this what could have also happened. So you need to know, you need to understand the right and wrong for different society could be different, and different legal systems could be different, and different the values and the practices of different societies could be different, and you need to keep all this in mind while speaking about this subject. So there are many dimensions. So as I mentioned, like there are so many dimensions to this story that there is no, I don't know even how, I don't know all of them, and I don't think I will be able to even discuss all of them today here. Like, and we don't have time, we don't have depth, and far more, I don't have a solution also. Okay, this is a problem, we don't know solution, but the problem, the objective of this lecture is for you to be aware of all these issues, and how do you live with such people. So the first issue that people talk about is privacy. In the rest of the talk I will talk about many of these points, touch upon, but what is the privacy? What's the privacy issue? Having data and what your private data goes somewhere, what you can do. Look, we worry about all these at different levels of notions of privacy exist. I'll give you an example of what happened. So we were part of like a data collection effort, a data set that came recently, like last year came, called Ego 4D. It's a first person large video, possibly the largest computer vision data set of ever. And we were luckily part of it. As I was telling you always, like, look, being in India, if you want to be one representative, I got the lottery and I was part of the last team. So we were the representative collecting data from India. And at some stage, one of our video was tagged for, it violates some issue. We could not understand what is going on. This issue. This is a first person video, people wearing GoPro and like wearable cameras and doing various things, etc. So it took time for us to understand what really went there, because when this video was, with the video there was somebody picking up a phone and the caller's phone number, that was a spam phone call, and was visible. Look, I don't treat like if you ask, anybody ask me my phone number, I give, or somebody ask me in the shop while entering, write your phone number, I write. For certain part of the world, this is super serious. So definition of privacy, then what level of information that you are leaking, not leaking, and what level of things that you can do could be very different. It's a culture, isn't it? So it's a practice. So what, and there is nothing right and wrong. And of course, over time the society changes. The practices we all change. We all make, say for example, when the phones came, we did not have any control of when to make phone calls. Now all of us have better control sometimes. We don't randomly, don't usually call people. We call, we sometimes talk to them, I think of what time it will be, what will happen when they say, I did not see any of your phones ringing. So 5 years back, 10 years back, if I am taking class like this, I am sure somebody's phone will ring in the middle. So this privacy issue is serious and people worry about a lot of privacy issue. For example, face verification when you do this, or fingerprint. Medical, you go to hospital. Who will keep this sort of information and how long? You need to have all this legal understanding before you go to the hospital itself. Paranoid of going there. It's valid on one hand. On the other hand, it is important to get the treated first. You need to have balance between both these aspects, the availability of the treatment and the privacy issue. And smartphones, laptops. So look at that. What level you can get privacy? I don't know how many of you realize. There's something called biometrics. Fingerprint is easy. Everybody knows fingerprint. Do you know one of the there's something called a soft biometrics. One of the very interesting soft biometrics is your keyboard stroke. The way you type. Ideally, you can today build a login without password. Only you type your name, login name at your speed between the gap between the key strokes. That is enough as a password to tell you that is you. So what goes when I'm interacting with a machine, with a keyboard, I'm providing my information at different levels. If you can exploit such biometrics, you are leaking privacy. So people talk about this privacy at different levels. Now, if you look at a typical machine learning based solution or deep learning based solution, you have training data. Using training data, you build a model, then you predict, then you test it at a deployment time. So you look at the full cycle. Now, when you have only a model access, you thought that you have not revealed any private information. No. Algorithmically, we have also gone to the next level where just from the model, I can talk about what training data I have used for doing it. So there are many ways of extracting private information from the models. You can invert models to infer information about the input data using the model's output. So you can worry about it, but if you are ever doing any deep learning training and using a model, it has all this information somewhere here there available in pieces, and that is why it is working. How much you can extract, how damaging is it, and what you should worry is an operating point that you need to decide when you are deploying your solution or when you are building a solution. I'll comment about such operating points later. Energy consumption in computer vision. Today, all the compute is on GPUs. The power bill that we are paying for our university is very high. We need to worry about the training time, testing time, all of them, in terms of the exercise. I think I'm sure that you might have read recent articles on the type of energy that ChatGPT used to build. So if you are working on huge training models, is it green AI? Everything is green today. Everything has to be green today. We got nice slogans. Whatever you get, you attach green today. Is it green AI? No. Now, I don't know whether you want green AI with no GPUs. And also I don't know. So there are worries, there are actions, there are concerns, there are solutions, many things happening in this world. So for example, now there's another set of people who talk about like, look, whatever you do, I can do like a different type of neural power controlled, models can be built. You can at least while deployment time, you can get interesting models, maybe small models, less power using models, so that eventually the world is green. So the full area of model compression. Initially, it had a lot to do with the edge computing and the style of things. And today, people also talk about like a trading time, power. There are many parameters that you want to optimize. Like I don't think it is just the number of parameters. How much energy, how much power, like a battery life on phones, and also like eventually what is that you are using for doing it. So a lot of interesting activity happening in this space. But is that making the AI green? I don't think so. And if you look at today, if you want to publish your next paper, you need 2% more accuracy. To get 2% more accuracy, you need to have one more set higher computing power required, some super power, high power transformers are required, more training data is required, more epochs are required. Where is green? Where? Back. Who is responsible? Who is responsible? Whose head we should chop? Yeah? Whose head? The programmer? No? User? No? Students? Who's? Data collection guy? So there's a data collection guy sent you So data collection guy's head should be chopped. No? No? Nobody is responsible.
Just law that this was a pillar and what was this pillar and which was law for. Because making anyone this principle, I don't think we have to get.
Okay, so his point is like we should just live with it. How do you make it better? Oh, okay. Today, I never thought this actually. I usually tell students, if you want to learn only one algorithm in deep learning, that is backpropagation. There's only one algorithm existing. Okay, he's saying the one algorithm solution for everything now. Backpropagation, I never thought backpropagation. Okay, what did you backpropagate? Failures. Errors I know how to backpropagate. This is the situation. So this came soon after this. I don't know if you. So I don't know. This was there is a nice paper, another paper called "It is easy to fool neural network" or something like that. Very nice title. So what they did was very interesting. They took a picture like this and they added some noise, and this new picture had a very different classification. Oh, this made all noise. This was in I think 2014. Around soon after this deep learning, everybody started to believe and salute this issue. This paper came, and they argued that this can be fooled. They were right. They were right, and you can do that yourself. Except that this noise is actually calculated. It's not like random noise you add; it will not happen. But some calculated noise you do, it will happen. And it will happen. You can do that. It's a nice form exercise. Laboratory exercise for everybody to do that. And but the problem is when this happened, nobody ever complained about this was known long time in machine learning. Such perturbations and their effects were known, except that they did not get enough PR, just like these people got. So what could happen now is like something like this. You change this, it production. You can do a startup on this now. Do you know for what? You can create t-shirts. You can get enough interesting things that you can wear so that nobody will know you what is it, etc.
Sports ball.
You can hold the gun which will be shown as T mug or something like that. And you can walk in front of surveillance cameras. Look. Dangerous. So what do we do? Removing surveillance camera doesn't help. The person can still walk with the gun. So we need so this entire thing, like why this happened, why this sort of things happen. If you remember your old machine learning, every time machine learning anybody teaches in the class, they draw you some red box and green box and draw some line. What happens is when you add this noise, the location gets perturbed. And in a high dimensional space when there are too many classes and very complex nonlinear boundaries, a small perturbation can take you across the boundary to some other class. It is not that by adding such small noise, anything can be made to anything. What you are adding is what is the smallest amount of noise that I need to add such that I can cross the nearest boundary and show you this funny example. But it reminded us that this sort of solutions are not always promised. And then we go back and ask the question that, okay, look, if you want to solve this problem, there is one more dimension we have to understand is like how is human being not getting perturbed and fooled very easily. So I made this comment earlier, like we know today that the way we recognize objects is very different from the way human brain does. So this coming closer of deep learning and neuroscience and the departure that we already had started. So we are not possibly building solutions that mimics the human brain. For like a critical domains, this becomes very important because when small errors happen, there is an associated cost, and cost is very high. So CNNs, people have done a lot. Like it is not like this area I mentioned, like this is nothing was done. Like the Rofergus visualization of the feature was the simplest thing. Then there are a lot of interesting visualization happen. What each layer has learned, feature visualization for different class of things, to saliency. So where somebody is looking, I need to just comment about that. So methods like CAM, GradCam, which are very popular tools. So they all have become more like probing tools. So when you do a deep learning toolbox, think of it. At the end of your paper, you can have a one section, 1-2 example where you say where GradCam is showing some qualitative example. They all have become now integral as a toolkit around you. You can try to explain what really happens, and what they do, they tell you why did I think that this is that object, or which portion of that picture gave me this idea about what is really going on. So that you can look at why this sort of thing, say for example like a label was assigned and which portion of the image resulted in that. So this GradCam, that track of papers possibly started to give you interesting visualizations, or so this sort of visualization heat maps where what part of the picture give this sort of thing. Like you can look at this is a cat, this is a dog, when it says where was it looking. So people talk about this as where was the neural network looking when it told that it is a cat. And the same idea got extended to vision language style of problems, like VQA problems. For example, when you ask the color of what is it, what is this element, or whatever, what this man is doing, what is she holding, you ask a question, then it gives an answer, and not only it gives an answer, it also tries to explain you by showing that, okay, by looking at this region, I believe that this is the answer, and at least it is explaining what it is doing. So, is this the end of explainability? No. But do we know how to explain? Yes. So, we need to understand what we are looking for when we complain that there is no explainability today. Here are more examples from image captioning. The next big complaint that people talk about is bias and fairness. Okay, so another very interesting domain where everybody complains because the train systems have started to perform bad or worse or for certain type of people. When people apply for say bank loans or jobs or some things, say it is not preferring certain type of people, maybe based on their gender. The popular example that has gone multiple times into the literature in the last few years have been based on the gender, based on the race, based on the geography, based on the color. Like that style of things are very easy for us to appreciate, and we are all sensitive to that. We understand that. So this sort of issues came. Say for example, machine bias. There is a software used across the country to predict the future criminals, and it is biased against blacks. Empirical study of like an apparent gender-based discrimination in the display of career rights or jobs, screening, loans. There are interesting studies people talk about when people give loan with an automatic scoring or automatic rating, etc., how they use it. This came into language, so vision was easy for people to appreciate. Then this entire story, like they looked at all the language models, they have the similar bias. So all this interesting arithmetic that we saw when we talked about word to vec or word embeddings, like man versus woman is approximately equal to king versus queen. So people started to see that it is also equal to computer programmer versus homemaker. Indirectly telling a lot of things that we don't want to accept. Many specific examples. For example, like what the word embeddings think as he and what a word embedding think as she. Or when should it use he, when it should use she. The stereotyping, the people, the careers, the jobs, the society, portraying in certain way which is with a strong bias, which possibly exists in the society, that get reiterated, emphasized, repeated by the machine learning algorithm which use this data. Who should be blamed? Somebody blamed the data, but this data was created by us. All these people only harvest from internet. They don't create any data, just got out, isn't it? Dialogue systems, sentiment analysis, chats, tons and tons of examples of such biases, discrimination. You want to stop? Speech recognition, another example. The performance, I think this is the accuracy axis of women and men. This is, I think, the error rates, opposite of accuracy. Race, white and black. And these are all products which are commercial, or big companies, big people, papers, systems. So the concerns are on the table. Now I think many of these companies or people took proactive steps to correct it. Some of the softwares or solutions were taken out, improved, at least the next generation. So there is a advantage of raising some of these is also like people are sensitive to the development, and the next generation solutions are less biased. So the fairness, there are in large studies on fairness and how to improve the fairness. There are very interesting viewpoints, formulations based on game theory, many other interesting mathematical formulations exist in this space. So I don't, very theoretical, very interesting space if you want to look at from a theory point of view. Interesting research happening. Formal definition of fairness and how that can be enforced, validated, verified in real situations and problems. So how do you address this? There are a lot of research happening, and I don't think there is a one answer. If there is a one simple, convincing answer, everybody might have done by now. So it's not that the researchers are don't want to have bias or don't want to absorb this into a solution. But so there are many standard tricks that people use in the typical machine learning pipeline. If you look at pre-processing or in-processing or post-processing, if you look at 3 stages of the thing, then you can look at many interesting strategies from sampling, statistics, what training data that you use, to while training what you can do, or while post-processing what you can do, at the deployment stage. So many ways in which you can minimize the negative effect of such bias in practical solutions. So let me go to the next level. Now everybody is talking about generative AI. Now what are the next set of issues in the generative AI side of things? We saw examples of that sort. No need of discussion on how the fakes are getting created or why these are wrong and right, etc. So what happens in the back? See, if you are familiar with this GAN style of framework for generation. Now what GANs are doing? GANs are say if you look at, there are 2, you sample from a noise or some distribution, and then you synthesize some sample. Then there is a real data and synthesized sample. Your distributor. There are 2 neural networks. One is a generator, one is a distributor, and your generator and distributor are playing each other. So if so that the objective of the discriminator is to separate between real and fake. Objective of the generator is to create an indistinguishable face. For us to think about, so this paradigm itself is very complicated for you to appreciate if you want to look at from this ethical point of view or a generative point of view. See, if you know how to separate real and fake, I can use it as a discriminator. If there is a classifier, so remember that the objective of this discriminator, the declassifier, is to separate real and fake. If you ever have a solution to separate real and fake, I can just plug in here. And the GANs are going to generate something that it can fool that. What you need is only to increase the capacity of this network at best. So this started to worry about what are the different ways in which you can do. Still there are there are many interesting attempts happen. So for example, one of the things that came up was a nice interesting data set where a large number of edits that you can do with face. For most of the time it is identity and expression. And create such a large data set and then use this and of course manipulations and using this for training in a supervised manner. So this is a problem that we don't know the solution. We still have no clue about how this problem can be solved, and hopefully in the next 1 or 2 years I am hopeful that there may be interesting results could come, because we are on the verge of some interesting threats going on at different places. So one of the first attempts was, or one of the interesting attempts in recent years was to create such attempt where we know what to do when you have a lot of supervised examples. As we talked about, any network could be today trained with sufficient examples. So let us use the same trick for deepfakes. The next was So another thing that happens today in the community, if you notice, is running global challenges. Run huge challenge so that you get diverse brains, people, participation, and like interesting attempts can happen, and people started to set up challenges. And global challenges where people participate and people show what is the state of the art and what type of innovative ideas can come and then they can be merged together to improve it. But there are fundamental questions also still people ask. Many interesting deep research questions that people are asking, like a deep fake. When you do, you are talking about separating this from that. Is it ever possible? For example, are participants able to differentiate between deep fake images and real people? About chance level. With a little bit of additional intervention, can people do? And so this possibly is not like a machine experiment, but it's a human experiment. Conduct with humans and see what type of statistics people report and what does it tell us about how hard or easy is this problem and where we are going to land soon. There is still different ways of looking. There is some new old techniques called watermarking. Okay, so it's old trick where we all studied when you learn image processing, we were learning image processing. What we were trying to do is do, say for example, transformation like a DCT or DWT, with different type of orthogonal transformation, single processing tricks, and then embed some watermark. And this watermark would be invisible in many cases, some cases visible watermark.
So how do we know if it's invisible?
This is invisible. You can see this, my name here. Here you can see my name, my company name. So invisible and visible. So invisible is, watermark is invisible. Watermark is invisible is important because you want it to be looking real. At the same time, like the information is embedded. My ownership information is embedded into it. Okay, so this is a very good old trick. I think today maybe people may not be teaching this in the courses. Like you can embed such watermarks, and there are nice interesting watermarks which became like you can print this picture, scan it and do this multiple times, still the watermark will remain. How robust is a watermark? Very lot of interesting research happened at that stage in watermarking. Now, once you have such watermark, you can extract. So, for example, like when you want to verify, somebody saying that, oh, this is my picture, or you can just check the ownership of the picture. Because ownership is embedded into some form. And this is a very, unfortunately, this trend was not explored enough for the fake, and today possibly there's a very interesting things could be done in this space. So, but this is still tricky. I think if you ever look at this now, this is possible for images. Because there is sufficient redundancy in number of bits, I can embed a lot of hidden information into this picture. It is not easy for text. So whether it is generated by ChatGPT or the students answer the question, I'm still struggling. There is no easy answer for that. So you can, because the number of bits in the text string is very small, to hide anything in that. So people talk about like this sort of watermarking techniques. How do we use it in the deepfake system? So I think there are many ways in which you can bring it. So one way to ask is like, assume I want to embed, say I use all the images which I use by GAN setting is watermarked. Is it going to be that my generated images also will have watermark? So what is watermarking here now? There are different levels you can think of watermarking. You can think of watermarking the training data, watermark, such that the generated output also will be watermarked. So your model is, so if all the researchers agree that all my trained models will have watermark, all the generated images also will have watermark. Or is it possible that I can embed watermark into the model itself? That's another way to look at it. There are maybe 3-4 different ways in which you can play with watermark and generation today. So this is yet another one where this watermarking is at the level of facial features. So I want to watermark in such a way that the facial features which are important are embedded into this thing which I can separate out later, even when you manipulate it. So just the same as your old requirement of watermark, when I print, scan, my watermark should remain. Here my requirement is that, okay, if you play with GAN, my watermark should remain. Watermarking of the models itself, not just the content. Is it possible to watermark the model itself today? The model means like your deep learning model, neural networks and the weights. Now the weights have usually very high amount of redundancy. That is why you are able to do model conversion. Now when you have such watermarking, like is it possible for that, for the models to be watermarked so that when you create a trained model, like some level of identity is available and anything that come out of it also can have similar identities if you want to really embed it. Still people try to do different type of things. For example, like if I have a neural network which is trained on something and I may not need any access to it, I can just give some random or a new set of examples and create mimic the model that you have. All your teacher-student learning paradigms possibly started to use that. So I don't need this, I can mimic your model. And when you create this, again this question comes, like whether your watermark and will the watermark be coming from here to there. So this issue of what is the authenticity of your model? Is it the connection? Is it the training data? Is it the weight? And where is your signature? And if what I can modify so that it become my model from your model. You can watermark the models itself in different forms. AI generated text. Not just images, isn't it? This is the latest news, if not past news. The type of noise that it makes and the type of issues that it creates, we are always worried about is it doing good or bad. I'm sure if I put it both, half the people will agree, half the people will be against for ChatGPT. Both can be there in this book. And how this sort of transformers, just like GAN, what they were doing. So this was also doing in a very similar way. Say we talked about this semi-supervised learning, learning from the data, learning from the crawled internet data, learning from pretext talks, etc. We talked about. What changed for it is not the GAN style of framework. It uses a lot of interesting pretext tasks, different type of tasks, starting from like word-to-vec used to do this missing word prediction type of simple task. We do now complex tasks so that you can, I think Resource Point out discussed a lot about this sort of issues and pretext tasks and how this sort of ChatGPT models could get trained and the associated transformers and the low-level details. This was supposed to be one of the first transformers that was done for machine translation. Now you can watermark text. Is it possible? There are people talking about such attempts. So these are all ongoing threats with different levels of success. So people talk about like what is good to look at it when you are watermarking text or when you are creating this. Is it ever possible for us to embed it? Is it a post facto or is it by looking at output can I do that? Or is that say watermarking or detection algorithm should be a side product of the ChatGPT or the generative model itself? They should, so all these issues like a virus and vaccine can come together. So these sort of issues are getting discussed at different levels. So there are a lot of interesting new business opportunities evolving now because ChatGPT has become it got seamlessly integrated to the business today. Now we also see this next level of issue about who is writing the content. Now how does some of this work? This look at one way to look at it is like how good or bad is the writing. Looking at the quality of text, quality of language. You can say whether it is written by human or who or what is it, etc. Just we talked about like how the keyboard keystroke pattern itself is telling about you. Similarly, like the language patterns are much more richer, possibly require more samples to make the decisions, but can tell you whether this is generated by who or what is it, etc. Characters are getting embedded. So this is this sort of many interesting things are happening in the ethics of generative AI today. To summarize, so we see like a introduction into a lot of interesting contradictions. I think what I want you to notice or take home message beyond the worries that I possibly planted in your mind is the conflicts that we have in our arguments. Technologically, starting from you want on one hand the compute to be like a very powerful, accuracies to be very high, and GPUs and environmental friendly and green AI. On the other hand, you want algorithms which are more compute intensive, so that they are fair and unbiased and many other things. You want it to meet the social demand of the most modern societies, and you also want to like meet the demands of the rural, underdeveloped or developing countries. So you want to know how do you balance between these two different requirements while talking about ethics and trustworthiness of AI and any systems or any technology. Robustness and privacy. You want both. Well, how do you balance between your requirements? Privacy and fairness. So people are increasingly like, I think there are interesting theorems and results and very formal things also come about, like what you can achieve, what you cannot achieve, and how do you balance between them, etc. So it is not that everything you can achieve an ideal thing that you can get always. But so while solving problems, you make errors. It is natural. Don't worry about that. As I mentioned, like this sort of worry should not stop you from solving the local problems. You should solve them, and you will worry about these issues in the appropriate form as and when we. There are human roles. We talked about multiple people in these systems. Whose head we should chop, we don't know. There are on the other hand, there may be standards and there are maybe discussions in the past in the classical software development, what to do, how to do, what not to do, etc. So many of them may be applicable here too, but that alone is not like maybe directly not applicable fully, or we may have to redo some of them for keeping the AI products, AI projects, AI solutions in mind. We need credibility. So we need this sort of solutions to be fully, like at the end of the day when you solve this problem, so this concern about the large number of concerns that I raised here, and possibly still I may be missing many concerns, and I'm sure there may be more concerns that will come in the coming years, is valid, and we need to address some of them, we need to keep them in mind while solving problems. Thank you. Yes, you can take some questions. General questions, this lecture, previous lecture. Yes.
Can I ask a question about bias and explainability? So say the model has learned some feature that we think is biased, even if it's accurate and predictive, and we think it shouldn't be using that. Is there any way to partition it out to say, don't use this feature?
Yes. So your question, I believe, is about like if you know that it has a bias, and if you know that it is coming from certain part of the text, etc. So you should be able to, like I say, one way to look at this, like pre-process the data. You pre-process the data such that this sort of biases can be removed from the picture. So I just want to, if you go to the solution that we talked about here, it will be in this box, pre-processing the data. but you don't know how to use that. So that is only making your life easy, isn't it? So the question is about like you are happy if it is providing you like an appropriate word.
Maybe I want to.
It is not really that. See, that is not a bias that people are worried about. At least you can control it. Yes.
Probably have time for just one more.
Yeah.
Not just one more question.
Yes, yes. You can take more during lunch also. Yes. Your network black box. So depending on what metric you are using for defining black box, I told you I know each and every bit of operations. That way, computationally, that is not a black box. Then we talked about functionally what each neuron is doing. We know fair amount of thing, what happens in the first layer, second layer, third layer, what happens we know. So at different levels, it depends on the black box at what level you are asking this question. So it depends on, say, embeddings at what, say, that may be a much higher level of a neuron. So if you look at it, CNNs, etc. So if embedding as such cannot be explained, that's where the embedding arithmetic possibly explains you, the visualizations of embeddings. Yeah. In our research papers. Yeah, so in research papers, as I mentioned today, for example, many research papers use GradCam, etc. as a tool to show some results, qualitative results. Like when you write a paper, you have tables, you have qualitative examples. With the qualitative example, you also show some explainability examples and say what it is doing. Not really, yeah. But that also shows it is not that okay, people, you are aware of it and you have thought about it. See, the example that I took was like when you have a problem, before you code, do you have a feel of what type of accuracy you will ever get? And how that is solving this problem, and when this problem, will this problem have a solution, acceptable solution, etc. Yes, it is not just publication part. Yeah, no issue. It's a yeah. It's a. So don't look at from a say publication should never be the end goal. That should first of all that should not be the end goal. Publication happens on the way. Research and problem solving should be there, and on the way you will publish. If you are just looking for publication, that's the bare minimum ingredient to do that. So earlier we used to say that you pick a classifier, you pick a feature set, you pick a data set, you compare all of them. Maybe nobody has done this in the past, you will get a paper out. But such papers also have no life. Nobody will ever do that. So you always do research which the others are looking for. For your excitement is one part. There are two reasons why you do research. One is for your own excitement. And the second is also this helps or this somebody else is looking for. So what that somebody else is looking for can be an immediate solution. Maybe somebody else will take up your work, follow your work, cite your work, to many other things could happen. So you understand that publication is not an end goal. It's an easy goal for you to start seeing as a student.
So I have a question. You said that like neural networks are even functionally capable. Like we can even see what is learning and what function is contributing to.
Yeah.
So in what sense we consider it a black box?
Okay, so the question is also you are saying it's not black box.
So yes, I
No,
think
it's depending on what. No, so both extremes. So I'm saying like you need to understand before you just buy this argument of black box, you should also understand that we know fair amount of things what is going on inside. You may not know every bit of it. It is okay, but it should not be taken as a shame for you to start with. Okay, yeah. Pardon? Inner? Uh, I don't know what 6 months is going to do. Yeah. So the question I told you, there are two parts to the story. So both party has to coexist for the right development of the society. You need to have development, you need to have criticisms. Both need to coexist. So if you have only the people who are worried about trustworthiness, development will not happen. Many of the social problems where AI can make an impact will not happen. And the needs that, but at the same time, you cannot have an uncontrolled way of things going. You need to have controls and checks and balances. So it is important in any democracy, there is a role for opposition. If you are not able to see the role of opposition in a democracy, that country will not flourish. That nation will not flourish, that democracy will not flourish. So both need to coexist. No, regulation also comes from such debates between the ruling and the opposition. So regulations will have to have roots at that level, otherwise it will become a dictatorial regime. So you have to learn from the history of the world how these sort of things will also impact the individual. Okay, thank you.
Thank you so much, Professor Dr. C.V. Jawahar. I think we collectively agree that we learned a lot today. Thank you once again, Professor C.V. Joy. It's an honor to have him here. He's one of the pioneers and a very well-known figure in computer vision across the world, and he's doing research and amazing work in just next to Nepal and in India since 1990s. And I think we can get inspiration and take a lot from his lectures, his interactions, and I encourage many of you, all of you, to interact with him during the lunch session as well. Thank you very much.